Hello, my name is Abdulazim Sayyed. My CW ID would be 503568871, and my topic is on embedded systems with real-time operating systems, challenges and solutions. So let me give you a quick introduction of it. Real-time operating system finds application in many different industrial systems, including avionics, nuclear power plants, process controls, etc. Without RTOS, systems would not be able to function properly, making it essential for mechanical or electronical systems that require real-time operations. Ignoring a deadline can have severe implications in many real-time systems. Today's world, embedded systems are found in everything from industrial machinery and medical equipment to cell phones and home appliances. Without the complexity of general-purpose computer, these systems are made to efficiently do particular tasks. Few components of RTOS are shown, such as the scheduler. The order in which these tasks are carried out is decided by the RTOS scheduler component. The other one would be symmetric multiprocessing. The number of concurrent tasks that an RTOS can process is known as symmetric multiprocessing, or its short form would be SMP. Function library. This is the interface that the application code and the kernel use to communicate. The function library is used by the program to communicate with the kernel and request things. Such other one is memory management. Memory allocation for all the processes handled by the memory management component. And the next one is fast dispatch latency. Rapid dispatch latency, sometimes referred to as a context switch time. It's the amount of the time that passes between causing the current job and starting the next one from the ready queue. Below is the diagram showed for the components of real-time operating systems. So the history of the RTOS is an emphasis of C programming replaced assembly in the embedded sector several decades ago. By increasing the level of abstraction, development productivity and the quality could not be enhanced, made possible by faster processors and improved compilers. A specialized operating systems created for embedded systems is called an RTOS because it guarantees that tasks are completed within predetermined time limits. It's an essential part of applications that demand real-time performance. So, what are its goals and purposes? The goals would be in today's world, embedded systems are found in everything from industrial machinery and medical equipments to cell phones and home appliances. To guarantee the dependability and predictability of embedded system, real-time operating systems are paramount. An 8% compound annual growth rate is predicted for the embedded software industry between 2023 and 2027, or 6,739,66 million USD. And the process of it is in order to control a particular function within a device, embedded systems are occasionally used as controllers. Despite being relatively simple, tasks that do not require a lot of processing power, some more complex embedded systems are also capable of doing a wide range of tasks. Though certain embedded devices software may be modified, this could improve expected functionality. The next subtopic is standard and platform. So an individual manufacturer can use prototype divided by the standard and protocol as a reference model. In order to process and progress the real-time operating system technologies, it's necessary to keep an open and competitive market. The following list of RTOS along with the standards they comply with. Target microprocessor specific code is written in an assembly language. Two is written in highly portable ANSI. ANSI. Below is the diagram given. Real-time systems are operating systems with time constraints associated with the system output. An RTOS is an operating system designed specifically for RTSS. RTSS can be divided into two categories. Soft real-time systems don't have hard deadlines and only experience performance degradation rather than the system failures when a system requirement is violated, whereas the hard real-time systems do. Each task has a priority, which aids the scheduler in determining which work should be completed first. Priority-based and non-priority-based schedulers are two types of scheduling algorithms. Preemptive and non-preemptive priority-based schedulers are distinguished by the fact that former chooses the highest priority task to execute regardless of whether another task is already in progress, while latter expressively waits for the lower priority running activity to exit the processor. The overall design of RTOS for IoT and its challenges. Since embedded systems uses an RTOS throughout the development, the IoT makes things smarter. The IoT has numerous difficulties, including large number of connected devices, security threats, rising system development cost, and decreasing production creation flexibility. These challenges bring up several criteria that RTOS must address. As a result, the RTOS needs to have the following features such as connection, scalability, modularity, security, safety, and innovation in failure set. RTOS solutions that are popular. RTOS, the industry has adopted a number of well-known platforms that each address particular demands and project specifications. RTL Linux, VRWorks, and FreeRTOS are these. FreeRTOS is known for being open source and is distinguished by its powerful community support and portability. On the other hand, mission-critical applications have come to rely on VxWorks, a commercial real-time operating system due to strong performance and dependability. As an alternative, RT Linux brings a, a distinct element to the scene by acting as a real-time appendage for the adaptable Linux operating system. So combining real-time features with the versatility of general-purpose OS. A lot depends on the specific requirements and the goals of the project when choosing one of these options. The types of embedded systems. Okay. So the embedded system based on performance and functional requirements would be embedded real-time systems, networked or networked embedded systems, standalone embedded systems, embedded systems on the move. Second category is performance-based embedded system based on microcontroller. It could be small scale, medium scale, and extensive embedded frameworks. And the third category is based on deterministic behavior. Hard-time real-time system, software real-time system, firm real-time system. Subcomponents and functions. A, a crucial component of the real-time system is the kernel, the fundamental services offered by the kernel, including scheduling, task management, timer handling, and IPC mechanism. These are the characteristics are what an RTOS ought to have. Memory management, harmonizing tasks, support for multiple USB ports, task generation, dispatch and scheduling, support for multi-core and multiprocessor systems, supportability of semaphores. Few of its pros and cons would be reliability, stability, scalability, availability, security, portability, and clustering. And its cons would be low multitasking, complexity, limited task, program crashes, driver requirements, etc. So the companies involved in would be RTS is widely used in a variety of applications in the automotive sector, particularly for FUSA compliance. RTOS is crucial for real-time decision making in a variety of applications in the aerospace and aviation industry. RTOS is an essential to the functioning of important medical device components in the field of industrial automation. Real-time control and monitoring system, or RTOS, are commonly employed. A few most popular RTOS companies would be DOS, Emboss, FreeRTOS, Integrity, Kale RTX, Linux ROS, MQS, Nucleus, ThreadX, etc. Some function threads are edge computing, integration of machine learning and AI, wireless network developments, hardware and software open source, cybersecurity, system on chip, rapid development, and prototyping instruments. So the conclusion would be the real-time operating systems needed for IoT must be extensible, modular, and flexible to the strict real-time specifications, small latency, support for multiple core processors. The RTOS will bring improved security, connectivity, scalability, safety, and the extended features. The future embedded systems makers will benefit from the RTOS by gaining a competitive edge in the system of IoT. By minimizing tasks, by minimizing risks, system is the subject of numerous research avenues discussed in the paper. These iOS-based, IoT-based RTOS trends can be categorized into five types based on research analysis conduct on these studies. Using RTOS to implement the system of things is one of these research directions. Embedded systems are a magical field with almost endless potential. Imagine being to manipulate system in your environment with just one or more gestures. Embedded systems can highly make the feasible emphasis on their effectiveness in real-time system application and potential future use. This has demonstrative application fields and the influence of embedded system on a variety of technical developments. These are the references, and one of the major would be Anthony Serio, a survey of real-time operating systems, who is a professor of Department of Computer Science and Engineering at Lake University. And that's it for today. Thank you so much for giving me this opportunity.